All right, welcome ladies and gentlemen. This is our video on the posterior leg. There are quite a few muscles for us to go through here. Before we start, I want to kind of give you some broad strokes here. So the posterior leg is going to be divided into two compartments. There's going to be a deep posterior compartment, and then there's going to be a superficial posterior compartment, okay? The deep posterior compartment, which we're going to start with first because we always go from deep to superficial, is going to contain muscles which are all going to run into the foot, okay? And they're going to get into the foot by passing between this medial malleolus of the tibia and the calcaneus. And that space right there is known as the tarsal tunnel. All of those tendons of the three deep posterior muscles of the leg are going to go into the foot. Okay, not just into the foot. Let me be more specific. They're going all the way down. One of them is just going to be a plantar flexor to insert here, but the other two are going to go to control the toes. Okay, so they're going to go all the way to the toes. All right, and then the superficial posterior leg is going to have muscles that all attach directly to the calcaneus and form the calcaneal tendon, otherwise known as the Achilles tendon. Okay, and those are three muscles that all attach to the calcaneus. They have no business going into the foot. They do not go through the tarsal tunnel. Okay, so that's how we can divide these two compartments conceptually and structurally. All right, let's begin. So looking at this posterior leg, okay, this is our tibia, this is our fibula, which means this is the medial side, and this is the lateral side over here. Okay, so we'll start with the fibula, and we know that this part of the fibula is the fibular head. Okay, inferior to that, we're going to find the fibular neck. Okay, then over here, we're going to see this part of the tibia, right? And remember, the tibia, the proximal part, is composed of two condyles, right? This is the lateral condyle, this is the medial condyle. So this right here is going to be the medial condyle of the tibia. Medial condyle, okay, of the tibia. This right here, notice that there's this ridge running on the posterior aspect of the tibia, and this is going to serve as an attachment site for one specific muscle that we're going to see later. This is known as the soleal line, okay? And down here and here, tibial shaft, fibular shaft, lateral malleolus, medial malleolus. This right here, this bone that's projecting posteriorly directly towards us, is the big old calcaneus, the famous calcaneus. Then we look distal to that, and we're going to see that there's this bone that is on the lateral side of the foot, distal to the calcaneus, articulating with the fifth and fourth metatarsals. This is our cuboid. That's the cuboid bone. And then we have right here on the fifth metatarsal, this big projection of bone right here is called the tuberosity of the fifth metatarsal. Okay. Then we see right here this bone that is articulating with these three cuneiforms. This is the navicular. It's a navicular bone. And then we have the three cuneiforms. So I'm just going to collectively call them the cuneiforms. Individually, they're named based on their position. So you'll have the medial cuneiform, the middle cuneiform, and the lateral cuneiform. There's three of them, okay? So those are cuneiforms. These are the relevant bony landmarks for us to know. Let's go to the first muscle. First muscle, the deepest muscle. This muscle doesn't, let me explain to you. This muscle right here is very, very deep, okay? And this area posterior to the knee joint, all right? When you have all the muscles in place, all right, in a normal human body, this is going to create a depression directly behind your knee. You can feel the depression right now. Put your hand right behind your knee, and there's a depression there, right? Soft spot. That is known as the popliteal fossa, and it contains an artery and a vein inside of it called the popliteal artery and vein. In the floor of that fossa, we have this muscle. It's a very deep muscle. It's right up against the bone. It's called the popliteus. Okay, the popliteus. The popliteus is going to attach to the lateral surface of the lateral femoral condyle. It's going to attach to the lateral meniscus, which is a piece of cartilage that sits inside the knee joint. And then it's going to insert onto the posterior surface of the tibia superior to the soleal line. So posterior surface of the tibia is just a good thing to know. So boom, right there. This muscle right here, can it contribute to knee flexion because it's posterior to the knee joint? Kinda, sorta. It's a very small, short muscle, okay? What it's believed to do is that it's responsible for unlocking the screw home mechanism, okay? I may make a completely separate video about the screw home mechanism because it's a interesting concept, but I'm just going to explain it briefly right now. The screw home mechanism is a mechanism in your knee joint, okay? So let's walk through it. When you go into full terminal extension of the knee, okay, when you go into full terminal extension of the knee, because of the bony surfaces that are inside of the knee joint between the tibia and the fibula, when you go into terminal extension, all the way the furthest amount of extension that you can go into the knee, your leg, okay, your tibia is going to slightly rotate laterally, okay? It's going to slightly rotate laterally. And before you start to come back into knee flexion, you have to rotate that tibia medially again to unlock that. Okay, so when you go all the way into terminal extension, this is known as a closed packed position of the knee. Physical therapists will know exactly what I'm talking about. That's a closed packed position of the knee. It's a very stable position of the knee. However, in order to get out of that, you want to rotate the tibia medially ever so slightly and then smoothly transition back into flexion. That's essentially what the popliteus does. That's what it assists with. Okay. Next, we go to tibialis posterior. So this is now starting the actual deep posterior leg muscles that I was talking about that run into the foot. So this is the first one we're going to talk about, which is the tibialis posterior, the deepest one of the three. The tibialis posterior is going to lie right in the middle. These three muscles are going to lie next to each other, 1, 2, 3. This one is lying right in the middle, and because it's in the middle, it's going to attach to that interosseous membrane, okay? And it's very, very deep, so it's going to attach to that interosseous membrane, one of the deepest structures. And then it's also going to have some fibers attaching to the fibula and some fibers attaching to the tibia, okay? And then from there, it's going to run through this tarsal tunnel, which is between the lateral malleolus and the calcaneus. It's going to run through that tarsal tunnel and have a wide array of attachments on the plantar aspect of the foot. It attaches to the navicular bone, the cuboid bone, the 3 cuneiforms, and the bases of metatarsals 2 through 4, okay? So it has a very wide range of attachments on the plantar aspect of the foot. And what is that going to look like? It's going to look like this, okay? It's going to look like this. So because of that, we can see, is it going to be able to control any of these toes and cause flexion of the toes? No, absolutely not. It doesn't run that far, right? It stops short right here. So it is going to control movements of the foot, okay? So what it's going to do is going to cause plantar flexion of the foot, okay? So the tibialis posterior is the plantar flexor of those deep muscles. Next, we have the Flexor Hallicus Longus. The Flexor Hallicus Longus, remember, hallucis is referring to the big toe. So it's going to run to attach all the way to the base of the first distal phalanx, to the big toe, which is here. Now notice, the big toe is on the medial side of the foot. However, this muscle belly for the Flexor Hallicus Longus originates on the lateral side of the leg. When I was first learning this, I thought this was counterintuitive. I was like, why is it that this muscle hallucis is not on the same side as the big toe? I don't know. God made it that way. Maybe there's some sort of muscular efficiency that is created by making it that way. Okay, so Flexor Hallicus Longus attached is going to look like this. Okay, so also travels through that tarsal tunnel. Okay, and then it inserts onto the base of the first distal phalanx. So what is it going to do? It's going to flex the big toe. It's going to flex the big toe at the interphalangeal joint and also at the metacarpal phalangeal joint. And in addition to that, because it's running, crossing the ankle joint posteriorly, it can also assist in plantar flexion of the foot. Okay, Next, we have the Flexor Digitorum Longus. Remember what I said. These three deep posterior muscles are just lying next to each other in bed. So the one in the middle, Tibialis Posterior, that real estate is taken up. The real estate on the lateral side is taken up. So the only spot we have left is on the tibial shaft directly. So this is going to attach onto the tibial shaft, and then from there, run through the tarsal tunnel and insert itself onto the base of the distal phalanges 2 through 5. So essentially the rest of the toes besides the big toe, right? So when it's attached, it's going to look like this. So what is that muscle going to do? It's going to flex these digits 2 through 5, right, at their distal interphalangeal joints, their proximal interphalangeal joints, and also at their metacarpal phalangeal joints. And in addition to that, along with the other muscles, it's going to assist with plantar flexion. All right, it's going to assist with plantar flexion. Now, before I move on to the next muscles, I just want to explain something real quick. If you saw my video on the lateral leg, you saw that I was talking about how those muscles of the lateral leg cause plantar flexion of the ankle, and because they're biased to the lateral side of the foot, they can also evert the foot. Okay, these muscles right here, notice that they're all crossing medial to the ankle joint. So in addition to their functions of flexing the toes and plantar flexing the foot, they can also cause inversion of the foot, right? So that's taking the foot. Let me draw an arrow over here for you guys. That's taking the foot and moving it in this way immediately. Okay, that's inversion. So these muscles can do that too. Okay. Now we cover these three deep posterior muscles of the leg. And now we can go ahead and talk about the more superficial ones, the superficial compartment that all attach to the calcaneus. All right. So the first one we're going to talk about is the soleus. So the soleus is going to attach onto the soleal line. Remember I said the soleal line is an attachment site for one specific muscle. It's going to attach to the soleal line. It's going to attach to the fibular head, the neck, and the proximal portion of the shaft. And then it's also going to attach right here to the middle 1/3 of the tibial shaft. So altogether, it kind of makes this U shape like this. Okay, it makes this U shape because it can't attach anywhere here because these muscles are already taking up that real estate. So it's going to attach like this, and it's going to make a U shape. Okay, and then from there, the muscle belly is going to create a tendon that's going to go down and insert onto the calcaneal tuberosity. So what is that going to look like? That's going to look like this. Okay, so it's a very thick muscle. The soleus is responsible for plantar flexion. Like all the rest of these muscles that we're all going to talk about from the superficial posterior leg are all plantar flexors. That is all they do. Okay, plantar flexion is a very, very important movement of the body. I mean, that's what allows us to jump, walk, jump and walk, right? Ambulate. So next one we're going to talk about is plantaris. Plantaris is a very small muscle. Plantaris is analogous to the palmaris longus of the forearm. It's a vestigial muscle. It may or may not be there. Okay. Does it have any function? Muscular function in terms of like actually moving things, not too much, but it does have proprioceptive function. And proprioception means knowing where your body is in space. If you can close your eyes and then have your finger touch your nose, that means your proprioception is intact, at least for your upper limb. Okay. And same thing with your lower limb. If you can close your eyes and then maneuver your foot to a specific point without looking at it, right? That is proprioception in action. Okay. And there are these small muscles distributed all throughout the body that assist us in proprioception, and all muscles inside of their muscle fibers, they have a neuromuscular bundle, a neuromuscular unit that is dedicated to the task of proprioception. Okay. All right. Now, without going too far into neurology, we'll just keep it there. Plantaris is going to look like this. Okay, it's going to look like that. Also inserting onto the calcaneal tuberosity. Okay, also inserting onto the calcaneal tuberosity. Next, the big boy, Gastrocnemius. This is going to attach to the lateral aspect of the lateral femoral condyle, and it's also going to attach to the popliteal surface superior to the medial femoral condyle. Mouthful. Just know lateral femoral condyle, medial femoral condyle. That's good enough. And then from there, it's going to have two heads. So one head attaches here, one head attaches here. Both heads run down and insert onto the calcaneal tuberosity. So that's going to be like this. Okay. So this muscle attaching to the calcaneal tuberosity is going to be able to do plantar flexion. These three muscles we just talked about, the soleus, the plantaris, and the gastrocnemius are all combining together to form the Achilles tendon, also known as the calcaneal tendon. And together, these muscles as a unit are sometimes called the triceps surae. The triceps surae. Surae refers to leg, and triceps because of three bellies. So the three bellies we're talking about is the medial head of the gastrocnemius, the lateral head of the gastrocnemius, and the soleus. We don't really count the plantaris in there because it's so small, all right? And sometimes it's not even there. So that's the triceps surae. So these muscles are very big and very powerful. They're essentially what make up the mass of your calf, okay? And one major thing we need to point out here is this. The gastrocnemius, notice, all the muscles we just talked about, if there's a superficial posterior leg compartment, they're all attached into the calcaneal tuberosity, so they all do plantar flexion. However, the gastrocnemius is the one that also crosses the knee joint. It crosses posterior to the knee joint. So what does that tell us? The gastrocnemius does plantar flexion and knee flexion. It can also do knee flexion, okay? The plantaris is also crossing the knee joint, but remember what I said. Very small muscle, can't really generate too much force. So I'm not going to say that plantaris causes a knee flexion. That's kind of absurd. So, but the gastrocnemius does. It generates a lot of force, okay? And another thing I want to point out is the fact that the gastrocnemius and the soleus are very different in terms of their muscular structure when it comes down to the microscopic level, when it comes down to the level of fibrils and mitochondria and all that stuff. And what do I mean by that? So if you're a person who, let's say, is like studying for the MCAT or something, or you're a physiologist, a muscle physiologist, or a physical therapist, you should know this too. There are different muscle fiber types. You have slow twitch fiber types and fast twitch fiber types, right? Slow twitch fiber types are responsible for giving us endurance, right? They're muscle fiber types that can last a long time, and they mostly work with oxidative phosphorylation in the mitochondria. Whereas the gastrocnemius is mostly composed of fast twitch muscle fibers, okay? So it can generate a maximal amount of force in a very short period of time, but that is short-lived. It doesn't have that much endurance to it, okay? So the gastrocnemius is more of a jumping or a sprinting muscle. It's for explosive movements, whereas the soleus is for a marathon or just a long walk, okay? That's what your soleus does. All right. And so that's the difference between these two muscles at a biochemical level, so to speak. Okay. And that's it. That's the whole posterior leg. All of these muscles of the posterior leg are innervated by the tibial nerve. Okay. And that's it. Gross anatomy is one of the most difficult subjects in the world. Luckily, it doesn't have to be. Anatomy is one of those subjects that needs constant verbal and visual repetition in order to get good at. What better way to reinforce this information than with the scientifically validated method of drawing? Neuroscience has shown us that we retain information better when we physically draw it out. That is why the Gross Anatomy Study Strategy Workbook is designed to walk you through all the layers of the musculoskeletal system, allowing you to draw the muscles into place. This is excellent for reinforcing muscle attachments, bony landmarks, muscle names, and actions. This will save you tons of time from mind-numbing tactics such as repetitive flashcards or passively listening to boring lectures. With this strategy, you can actually begin to enjoy studying again and have a much better way to retrieve the information. Order a copy of the Gross Anatomy Study Strategy today at the link below so you can spend less time being stressed and more time being blessed.